So we had this question about vehicles, police cruiser chasing a truck, and the second part asks us about what happens 5 minutes later. What we found the rate that these vehicles were, the rate at which the distance was changing between these vehicles um, at time zero, right? That was in the last video. So now the question is, what about 5 minutes later? So the formulas are all identical here, but we need to recalculate all the fixed quantities, right? For example, the truck traveled for 1/12 of an hour, 5 minutes, 5/60ths reduces to 1/12. So 144 divided by 12 is 12 kilometers. So we had the initial 30 kilometers at time zero plus the 12 that it traveled in the next 5 minutes. So the new quantity for x at time 5 is going to be 42 kilometers. And the same for y. In 1/12 of an hour, the police cruiser travels 15 kilometers. You can do the math. And remember, the police cruiser is getting closer to Sioux Falls, so the new distance for the police cruiser is 20 minus 15, which is 5 kilometers. And we can use the Pythagorean theorem to figure this out. Let's take a look at the geometry. So again, we were looking at this animation, and I'm going to stop it here when we get close to 5. And you'll see that the hypotenuse is almost identical to the length of this leg that describes the distance of the truck from Sioux Falls. Okay? And that's going to be important because in the last problem that we did, right, the question was, does it make sense? And we found that this rate was positive, which means the distance between the vehicles is getting larger. Well, if the distance is getting larger, then the new distance we calculate at time 5 should be bigger than this 36.06 that we found last time. So we'll have a way to think about the physics and the physical quantities and see if it all makes sense. So coming back to the geometry, this is the situation we're looking at where one leg is 5 and the other leg is 42, so we can use the Pythagorean theorem here. So we still have the same equation. We still have the minus sign because the police cruiser is still traveling towards Sioux Falls. So that leg, that vertical leg of the triangle is getting smaller. And we plug in the value in kilometers we found from the Pythagorean theorem. And divide through by the 42.3 kilometers, and you see the new value. Now notice this is 122 kilometers per hour approximately. And remember that the rate that we found in part A was just less than 20 kilometers per hour. And again, it has everything to do with the geometry here. As the police cruiser gets closer and closer and closer to this right angle, even though the police cruiser is traveling very fast, these rates are so similar that the police cruiser isn't really, even though its speed is increasing, it's not decreasing this hypotenuse, right? The only thing that's and it's not doing anything compared to the increase that the truck is doing by moving to the right. The truck is what's actually causing the biggest increase in the hypotenuse, despite the fact that it has slower speed. So again, I want you to think about the physics involved and make sure that when you get an answer, it actually makes sense. One other tip I want to point out is please track your units all the way through. So we have kilometers squared per hour and kilometers squared per hour, and then we're going to divide by kilometers, and the answer does in fact come out to be, if you track the units, it does come out to be kilometers per hour. So definitely a pro tip there. Think about tracking your units all the way through so you know when things can be added and subtracted from each other and when we're dividing by the right quantity. All right, I have another example coming up in part 3.